So the next part of this is going to be generalizing all this to what's called a trapezium rule. And you'll see when you look at the formula booklet of what you'll be given in exams, the trapezium rule is given as this horrific looking thing, which I've highlighted. And this is letter for letter what you're going to get. So let's kind of break down what this means, and we'll build up towards why we're going to get there. So first of all, here on the left hand side, that's just the area of y between b and a, and it's saying that it's approximately given by half times, well, first of all, h, that's one of our first red box. What is this quantity h? And you're also looking at kind of adding up all of these, but then you're also getting this kind of double factor for certain y values. And actually, you probably can work out what those are if you looked at the previous example. For example, maybe there's a double factor linked here with this, maybe something here. So if you want to have a go at generalizing this, have a go. But one thing I will say is, just to agree on some notation, let's just say that, for example, here, we start off labeling that coordinate as y0, as our y coordinate, sorry. And this is y1, y2, y3, y4, y5, and, well, I know it's technically y6, but in general, if we have n bars or n trapeziums, this will be yn. And finally, h, we can just define as being the width of a bar. I know it's really confusing because h we always see as being height, but you'll just have to take my word for it. This is what you'll have to get used to seeing. So if you want to have a go at deriving this, go for it. Otherwise, I'm going to try and generalize this with you guys. So here I'm looking at maybe the area of the third trapezium. So that's going to be this one here. We've kind of done that already with the last one. We know that this area here, I'm going to still use this with my height, with my width h, sorry. So it's going to be half of the sum of the parallel sides, that's y2 and y3. And it's going to be times the distance between them, which is h. But what is h then? And I think probably the best way to visualize it is just if you have numbers. Let's say, for example, b was 8 and a is 2. Well, if you look at it intuitively, that's like saying that you have a whole distance of, well, 8 take away 2, which is 6, and you're trying to split that between 1, 2, 3, 4, 5, 6 trapeziums. So if we generalize that, rather than saying 8 and 2, we're saying that h we can find by saying is a difference between b and a, so b take away a, and you're then dividing that between n trapeziums. So that's where that h comes from. Now, if you go through and actually write out all of these trapeziums, which I've done here, nicely color-coded, you can see that actually there's some things in common. So you're going to be doing half times the sum of the parallel sides times the distance between them, but then each one of these terms has this half and this distance between them in common. So actually one thing I could do is I can just factorize out that half h. So that's what I've done in the second step here. Half h is now factorized out. And I've just got everything else left inside of it. And actually, since I'm just adding them all together, I technically don't need these brackets, so I can just get rid of them. And now that we're rid of them, one thing becomes a lot clearer, and that's that when you add up all of these, you're going to get these repeated terms. This y1 and y1, this y2 and y2, y3, y3, y4, y4, y5, y5. And actually the ones that you're not going to get doubling up are going to be the leftovers ones, which are this y0 and yn. Or to relate it back, it's going to be our, well, starting height and ending height. And that kind of makes sense when you're adding up these trapeziums. You're going to get those coordinates doubled up. So if you're going to group them all together, well, these two lonely ones are going to be on their own, and all of these ones here are grouped up and they are all doubled. Hence, that's where this equation comes from. And if you're going to use this, well, in the context of a question, I personally would say using this concise method is better, just because it saves you a bit of time. But again, it doesn't really matter if you want to do it with the more intuitive method. So here, if I'm looking at the previous example of saying the area under y equals log x between 1 and 3, here's my y coordinates and my x coordinates. So again, I can say, well, it's going to be half times h, and h in this case for my limits are between 3 and 1, and I'm splitting that between 4 trapezium, so there. And finally, I can say, well, y0 is going to be 0, yn is going to be 0.477, and finally I have 2 lots of every other y coordinate, so 0.176, 0.301, and 0.398. And if you put that all into the calculator, you should get the exact same answer as before, 0.5568. Again, you can put this unit squared down if you want to.